Hello, greetings to everyone and welcome to this video lecture on cosmology. In the last lecture we spoke about the problem of the origin of the universe, which at first was left unattended by science, was taken over by the scientists. Then we saw how the scientists took up the issue of the origin and come forward with a plausible explanation of the origin and development of the universe through a Big Bang theory. Big Bang theory has the strong support from Einstein's theory of relativity and quantum theory. Now, in this lecture, we try to understand the present state of the universe with its stars and galaxies and the microwave background radiation. In line with it, we also understand the scientific position with regard to the existence and end of the universe through theories about it. In connection with the Big Bang theory, there emerged the problem of the leftover matter that is now to be discussed. In the case of matter-energy conversion at the Big Bang, at the end of the mutual annihilation, while most of the particles and antiparticles disappeared in mutual destruction, one out of every billion particles, that is one proton and one electron, survived. Thus, by a mystery, there was an excess of matter left over at the end of the Big Bang process. What we see everything in the universe today is said to be made out of this 1 in a billion excess particles left over in this way. The stars, galaxies and planets, and finally the human race itself is made out of this 1 in a billion particles, that is one proton and one electron left over in this way. Suppose if the matter energy interaction had produced no excess of matter, everything might have been annihilated, leaving no matter at all. In other words, if the interchange between particles and energy went on forever, there would be no matter left to form the stars and the galaxies. But some matter was left over as the final separation of matter and radiation took place in some mysterious way. From then onwards, the two took separate parts. Thus, we have the present world with the stars and galaxies. Radiation had nothing to do and got cooled to 2.7 Kelvin, as at present the temperature in the universe is. As for matter, at around 900 million Kelvin, many neutrons attached themselves to protons to form helium. At the same time, cooling allowed the remaining protons to pick up electrons and to form hydrogen atoms. At the end of 3 minutes 46 seconds after the Big Bang process, the universe was transformed from a mixture of energy plus matter into mixture of 25% helium and most of the rest hydrogen. These events during the first few minutes in the development of the universe shaped it to be what it is now, our universe. In 1964, the Nobel laureate Arno Penzias and Robert Wilson discovered the cosmic microwave background. They shared the Nobel Prize in Physics for this work in 1978. Cosmic microwave is understood to be the echo of the Big Bang itself. Penzias and Wilson, while working with a very sensitive microwave detector to measure the background radio signals or waves coming from the Milky Way, they expected some faint signals. But to their surprise, they found a much stronger signal than one they anticipated was coming from all directions in the sky. They pointed the antenna to different parts of the sky for weeks and months, and they found no change in the signal coming from all directions in space. This indicated that the radiation is from beyond the solar system and even from beyond the galaxy across most of the observable universe. Penzias and Wilson concluded it to be a genuine cosmic microwave background signal. At this point in Princeton University, a team of scientists was actually building an antenna to test the existence of the cosmic wave background, whose existence had been predicted by the physicist P.J.E. Peebles. Peebles pointed out that if the universe has evolved from a denser state, then it might be possible to detect leftover radiation from the hot phase till permeating the space today. In his calculations, Peebles found that a very strong flood of radiation is needed if the Big Bang is to take place. But with the temperature of the universe cooling down, matter predominated and radiation lost its intensity. Since 1965, many observations have confirmed the nature of cosmic microwaves and found its temperature to be close to 2.7 Kelvin. The significance of this discovery is that, having taken the exact temperature of the universe today, we can calculate the temperature of the universe at the earlier states, that the universe as more compressed and density were more increased until we reached the state of the universe at the time of the Big Bang. It was an advantage for the scientists to calculate the temperature at the time of the Big Bang from the present temperature of the microwave background. Now we know that the galaxies are formed from the leftover matter. We have seen at the end of the Big Bang process, by a mystery of nature, there was a tiny excess of matter left over. Everything in the universe today, the stars, galaxies and planets, and finally the human race itself, is made out of this leftover matter. We understand that galaxies are made out of this leftover matter. Now, how are we to understand the galaxies or to explain the galaxies? Galaxies are huge clusters of stars that hold together by force of gravity. They are so big that they have sometimes been called island universes. Galaxies seem to be scattered in space. They are formed of hydrogen and helium produced at the Big Bang. They got formed into millions of islands of gas clouds of hydrogen and helium. These condensed due to gravity and rotated. When the original super dense material stuff of the universe exploded, billions of islands of gaseous matter were formed in space. They are rotated each with its own speed of rotation. They took different shapes depending on the speed of rotation. Those with very low rotational speeds assumed nearly spherical shapes. But most of these gaseous islands had such high rotational speeds that their bodies were flattened out into the shape of disks. From those edges, spiral arms were formed. The center of the galactic disk was formed by a multitude of protostars rotating on regular circular orbits around the center of the galaxy, whereas the spiral arms were formed by highly diluted dusty gas. The galaxies have thus come out in different shapes and sizes. Accordingly, it is observed that there are three major kinds of galaxies in the universe, namely spiral, elliptical, and irregular. Spiral galaxies have a central nucleus with great arms trailing around it. The Milky Way and the Andromeda galaxy belong to this group. The spiral galaxies comprise some 80% of the galaxies in the universe. Elliptical galaxies are elliptical in shape without any spiral arms. These account for about 17% of the known galaxies. Irregular galaxies, as the name suggests, show no definite geometric patterns or shape. There has been suggested that irregular galaxies are young galaxies, while spiral galaxies are middle-aged and elliptical galaxies are old. Now, most of the observable galaxies seem to be scattered in space more or less at random, but many galaxies clustered into groups which may contain as many as several hundred individual galaxies. Our own galaxy, the Milky Way, belongs to a cluster of some 24 galaxies called the local group. This group covers an area of about 3 million light years in diameter. Milky Way contains about 100 billion stars. It has a diameter of 100,000 light years and a thickness of 2,000 light years. There are about 100 billion such galaxies so far discovered. The two nearest galaxies are the large Magellanic Cloud and the small Magellanic Cloud. The large Magellanic Cloud is about 155,000 light years from us, with a maximum diameter of some 40,000 light years and contains some 5 to 10 billion stars. The small cloud contains only 1 to 2 billion stars. Following the nature of galaxies, we have the account of stars, its formation and its supernovae process of its death. Further, connected to the stars, there are black holes and quasars. Following this, it is easily understandable the narrations of our solar system with our planet Earth and the human beings emerging out of it. All these are explained as interrelated from the point of view of Big Bang process of the origin of the universe. Now, from the Big Bang explanation of the universe, if we are to look for a plausible understanding of the expanding universe, the Big Bang theory automatically evades the paradoxes of an eternal cosmos. Big Bang process shows that the universe started to exist has a finite age. It began in some sense wound up and is currently still busy unwinding. It is clear now why the night sky is dark, because we can see only finite distance into space, about 15 billion light years, and this being the maximum distance from which the light has been able to travel to Earth since the beginning. And there is no difficulty in understanding why the universe is not collapsing under its own weight, because by the effect of Big Bang process, the galaxies are flying apart, which avoids falling them together at least for a while. We know that the Big Bang theory is based on Einstein's general theory of relativity. And one of the main consequences with general relativity is that the affairs of matter cannot be separated from the affairs of space and time. This linkage has profound implications for the origin of the universe. That is to say, as the mathematical physicist Paul Davies says, if space is infinitely shrunk, it must literally disappear like a balloon that shrivels to nothing. And as per the linkage, the space, time and matter also must disappear. There can be no time without space, we know that. Thus, it is clear that material singularity is also a space-time singularity. Moreover, as the laws of physics are formulated in terms of space and time, at a point where space and time cease to exist, these laws are beyond applicability. Therefore, the laws of physics must break down at the singularity, because the space-time aspects do not exist there. Now again, based on the matter-space-time linkage, if we imagine the cosmic movie of the expanding universe running backward, then it will be that the galaxies get closer and closer together until they merge. Then the galactic material gets squeezed more and more until a state of enormous density is reached. On the other hand, if a universe started to exist, let us say with a Big Bang, how did it start to exist? It is impossible from the scientific point of view to imagine a universe that exists before the Big Bang, like a kind of cosmic egg. Then naturally it takes us to ask the question, was there a creation event for the Big Bang? this remains a point to be clarified. From the scientific point of view, it is clear from what the Nobel Prize winner for physics, Leon Lederman, writes. According to him, he writes, "A story logically begins at the beginning, but this story about the universe, and unfortunately there are no data for the very beginning, none, zero. We don't know anything about the universe until it reaches the mature age of a billionth of a trillionth of a second. That is, some very short time after creation in the Big Bang. When you read or hear anything about the birth of the universe, someone is making it up. Only God knows what happened at the very beginning." So, the explanation of the origin of the universe, science sends us back to philosophy, because the mystery of the origin is not completely revealed. Accordingly, it seems reasonable to accept, together with Aristotle, a prime mover or first cause in a cosmic chain of causation. Now, taking or accepting the Big Bang process of the origin or explanation of the universe, there are many theories regarding the existence of the universe and the end of the universe. There are theories explaining the universe with the Big Bang other than a creation account. Scientists and philosophers also think differently about it. It is speculated that could there be a different explanation for the Big Bang development of the universe? Or people ask, could our universe start to exist from the ashes of another universe? Now, these are the questions still prevailing in the minds of the scientists and thinkers while trying to give a meaningful but rational explanation of the world. Stanley Jaki, a Hungarian-born Benedictine priest who is specialized with a doctorate in both physics and theology, has made a detailed study of ancient beliefs in cyclic cosmology. He points out that Chinese dynastic system reflects a general indifference towards historical progression in linear pattern rather to a cyclic pattern. Their chronological dating restarted with each new dynasty, that all events, political and cultural, represented a periodic pattern of the interplay of two basic forces in the cosmos, namely the yin and the yang. Success was to alternate with the failure, as was progress with the decay. Similar conceptions about the universe in cyclicity is found in Hindu, Babylonian, Egyptian and Mayan cosmologies. Greek philosophy too was steeped in the concept of eternal cycles, in that the Greeks believed that their culture represented the top of the cycle, the very pinnacle of progress. To the Big Bang explanation of the universe, some scientific theories have made attempts to reinstate a cyclic cosmology based on the Big Bang conception of the universe. One such theory is seen with Einstein's general theory of relativity. When Einstein formulated his general theory, scientists still believed in a static cosmos, and this prompted Einstein to fix up his equations to create a gravitational-levitational equilibrium. The Russian-born Alexander Friedman, studying Einstein's equations and their implications for cosmology, came out with several results. One of such results corresponds to a universe that starts out at a Big Bang and expands at an ever-diminishing rate and then starts to contract again. The contracting phase mirrors the expanding phase, so that the contraction gets faster and faster until the universe disappears at a big crunch, a catastrophic implosion like the Big Bang in reverse. Accordingly, one could imagine of an oscillating universe graphically that it is in course of expanding cycles. That is, The size of the universe varies with the time as it expands and contracts in a cyclic manner. The cyclicity of this model considers only the gross motion of the cosmos and ignores the physical process within it. But applying the second law of thermodynamics to the physical process within, the cyclic motion demands that these processes generate entropy and that the total entropy of the universe goes on rising from one cycle to next. The result is rather curious effect discovered by Richard C. Tolman in the 1930s. As we know, entropy involved of the second law of thermodynamics is based on Einstein's equation of matter-energy conversion, that is E is equal to mc square. That is to say, when work is done, energy is expended, and in the process of work done, some energy is converted while some energy becomes unavailable or it remains wasted. This unavailable energy is called entropy. In the process of work, energy and entropy are inversely proportional. Hence, if energy decreases, entropy increases. That is, when energy becomes minimum, entropy becomes maximum. On this ratio, Tolman found that as the entropy of the universe rises, which naturally makes the cycles to grow bigger and bigger and last longer and longer, the upshot is that the universe is not strictly cyclic at all. In the 1960s, the astronomer Thomas Gould believed to have found a truly cyclic model of the universe. Gould was struck by the fact that expansion of the universe worked against thermodynamic equilibrium by continuously cooling the cosmic material. It seemed to Gould that the rise in cosmic entropy could be attributed to the fact that the universe is expanding. But this conclusion carried with it the hint of a remarkable prediction. That is, if the universe were to contract, everything would run backward. Accordingly, time would flow backward. And Gould pointed out that this reversal would apply to all systems, including the human brain and memory, so that the psychological arrow of time would also be reversed. That is to say, we would remember the future instead of the past. Now, this is the cyclic explanation of the universe and the possible consequences that could be thought about the universe as existing with the Big Bang. Now there is another theory called self-contained universe put forward by Stephen Hawking. Compelled by the time-symmetric universe idea, Stephen Hawking played with a sufficiently probable model of the universe as part of a quantum cosmology program. Analyzing for a theory of a self-contained universe, he probes into the possibility of a universe that could be thought as existing as a creation without creation, where he could avoid the interference or unnecessary attribution of a creator or a creation. According to him, there is a particular family of histories that are much more probable than others. These histories may be pictured as being like the surface of the earth, with a distance from the North Pole representing imaginary time and the size of a circle of constant distance from the North Pole representing the spatial size of the universe. The universe starts at the North Pole as a single point. It will be seen that as one moves south, the circles of a latitude at constant distance from the North Pole get bigger, corresponding to the universe expanding with imaginary time. The universe would reach a maximum size at the equator and would contract with increasing imaginary time to a single point at the South Pole. Even though the universe would have zero size at the North and South Poles, these points would not be singularities any more than the North and South Poles on Earth are singular. That is to say, the laws of science will hold at them, just as do at the north and south poles of the earth. Which he wants to explain that there is no point of this north pole and south pole where the laws of physics are invalid, or there is no place where no time, no space, where laws of physics are not applicable. The implications of these histories are profound, pointing to the issue of talking about a creator for the universe. As Stephen Hawking himself remarks, so long as the universe had a beginning, we could suppose it had a creator. But if the universe is completely self-contained, having no boundary or edge, it would have neither beginning nor end. It would simply be existing. What place then for a creator? That's a question he asks. Hawking's proposal is for a universe without a definite origin in time. But the theory presupposes that the universe has not always existed. This naturally raises the doubt whether does it not means that the universe created itself? In that case, it is better to say that the universe of space, time and matter is internally consistent and self-contained, that its existence does not require anything outside of it. Specifically, no prime mover is needed. Does it mean that we are to regard the universe as forming a closed system containing the reason for its existence entirely within itself? It means that given the laws of physics, the universe can, so to speak, take care of itself, including its own creation. But the question remains still that where do these laws come from? At the end, Hawking, who claims to have a reasonable explanation without having any reference to God, falls a victim of doubt and uncertainty. Therefore, on this basis, he writes, even if there is only one possible unified theory, it is just a set of rules and equations. What is it that breathes fire into the equations and makes a universe for them to describe? Further, he observes and doubts the usual scientific position that the usual approach of science of constructing a mathematical model cannot answer the questions of why there should be a universe for the model to describe, or why does the universe go to all the bother of existing? Is the unified theory so compelling that it brings about its own existence? Or does it need a creator, and if so, does he have any other effect on the universe? And who created him? Such questions are always being asked by human beings regarding the universe with the Big Bang explanation. So, the man presented as the most brilliant theoretical physicist after Einstein ends his book with the acknowledgement that science does not have the last answer to the questions raised by the existence of the universe. Specifically, the theories about the origin of the universe are good theories, but the big philosophical question remains open. Why does the universe exist? How did it start to exist? Now, with these questions, we stop our series of lectures on cosmology, and it is left to each of the individuals for further readings and reflection and to have their own answers. And if it is an answer which makes very relevant to the possibility of a creator creating by his intelligence and will, and to explain the universe which is scientifically explained with the Big Bang theory, is accepted, how are we to accept it with a creator or without a creator? If it is a creator, how do we accommodate scientifically a creator getting involved for the beginning of the universe through Big Bang? So wish you all the best. Thank you very much.